Hey, welcome back. I'm checking the stream, making sure that we have some audio, some video, just a quick check here, and then we'll get started with some new developments in our advanced dynamics class. So just giving this a second, we'll see if it catches up. I think it's going. Let's ensure that we have some audio, some video, just a quick check here, and then we'll get started with Looks good. New. Okay, so the latest kind of logistics is I made a little Julia coding assistant. If you click this link, it will bring you to Copilot, so Microsoft Copilot. When I click it, it brings me straight into like a Julia assistant thing here. The first time you do this, it will ask, like, do you want to install this? Like, do you trust Ryan Cooper? And if you want to build it yourself, I can share the pre-prompting that I used. I just gave it some. Let's go to all agents, edit. I gave it some instructions on, like, okay, don't make sure you give me code that doesn't give errors. I want you to reference plots, diffeq, and symbolics. And I gave it these links to Julia code so that it'll so hopefully it pulls from these and not from other websites. Try to keep it to 20 lines, but just some general kind of instructions. The main thing for AI is kind of give it a role, specify the like give it a small box to play in. So here, because we're doing mostly like physics sort of simulations, really we just need like plotting, differential equations. Symbolics is kind of cool, and I'll show an example for pendulum, like how we can do a little bit of like vibe coding. So I build these AI tools to try to help. So I built this to try to help with the class, to help you explore dynamics with Julia. So but if you do not want to support AI industry, that's totally fine. You don't have to use this coding agent. If you have different coding agents that you want to use, then that's also fine. And if you don't want to support AI at all, then documentation is way better to begin. Like, it's better to just use this documentation and kind of get things working the way you want. The neat thing is, like, when you use a coding assistant like this, sometimes stuff just ends up working right out of the bat, so you don't get any errors, which is sometimes that feels nice to just jump right in and start getting results. Okay, so there's a Julia coding assistant to help with kind of playing around and like doing some physics. And then we have let me show the student preview so you can see. So I'll see exactly what you see in this. So in our project 1, my plan is to do 3 group projects for this. And they're longer projects, a little bit open-ended. You can choose like how you want to do stuff, and I think I have to join a group. So, all right. So people are joining groups. That's great. I'm gonna try joining group 1. You can kick me out afterwards, but let's see what happens. Joined. So now I'm in a group, and I can start the attempt. So now that I started this attempt, there's a list of these repositories. They're all the same project to start. They're public because I want you to be able to see what other people are working on. Like, this is not meant to be a project where you have to do everything yourself and hide what you're doing. It's okay to share code with each other and kind of work through things. So here, this would be like my project 1 from my group. And if I want to try doing some initial coding, I can grab the link to this Project One notebook. So in here, so I'm gonna grab that hyperlink, copy it, and I think I have to run, so let's run Julia, and then import Pluto, and then I can say Pluto dot run. There we go. It gives me some options for things that I'm working on. The pendulum equations, I'll show that one tomorrow. But I can paste right in that Project One work. And now I've got, right now it's pretty minimal. Like there's nothing in here to help me do this project. But it has an explanation. So there's a little diagram. This little dashed green line is the path that this thing is, like, as it's swinging around in a circle, it's oscillating and moving around. So I can say run this notebook code. That's okay because we got it from GitHub and it's not really running anything yet. And this is, again, if you don't want to use AI, that's totally fine. But let's give it a shot. Julia Assistant. All right, so in this case, like if I just want to think about a pendulum kind of swinging, and I'll show some. Yeah, let's start with just my last discussion, since it already loaded up some stuff. So what I did was I told it what my Lagrange is. So I'm giving this AI, like, hey, I have a 1/2 ml squared theta dot squared, and then my potential energy is mgl 1 minus cosine theta, and I want you to show me what is this Lagrange. And so then it comes up, shows me what equation I typed in, and there's that. Then it's going to use this symbolics and then start creating this Lagrange stuff. So I could copy this, paste it in here, and then copy this, paste it in there. And then I think, oh yeah, let's just wrap it all and begin and end, run that. One thing that I can do that's a little different here is add this LaTeXify like this. And then I think it will turn these equations into LaTeX equations. So LaTeX is just a way of like formatting. It's a general like documentation formatter, like it can make documents and stuff, but it's come to mean like a LaTeX equation is a certain way of writing that LaTeX. So there's my Lagrange, and then I could grab this and let's see where that one goes. Oh, derivative is not defined. Oh yeah, so I was having trouble, and this is something that can come up with AI. Like it thinks maybe it made this function up, or maybe it was in some old documentation on some other website, but it ended up not working. So how did I do this? Came down. and I know I'm scrolling through symbolics dot. So the symbolics dot derivative didn't work, or maybe it did. Lag. Was it just derivative? I think it was lag, comma, theta, like this. Derivative not defined. I don't think it was symbolics. So even with, was it differentiate? Let's just tell it. And then symbolics dot derivative. Do I have to write dot derivative? Let's try that. Names. So differential, symbol, variables, more. So this is telling me like all the different things that I can do with symbolics. But it's still giving me some trouble. Let's try that. That is what AI told me to do. Okay, there we go. So then I end up with like a pendulum equation here, which is kind of cool. And that's kind of the first part of this, is like, how do I get to the Lagrange? And what you'll have to do is define what is kinetic energy inside this moving reference frame. And we can work on that together. Like, this is not something to do on your own all in one night, and something that you should work on with people in your group too. The power here of like Lagrange methods, and then also like combining it with code, is that it's a lot easier to define kinetic and potential energy and then start doing derivatives that way, rather than trying to do everything from scratch. Like, if we tried to build the free body diagram on this thing as it's moving around in a circle, like, the acceleration is pretty complicated here. There's a lot of like three-dimensional motion happening. But in terms of Lagrange, everything's really just happening in this one rotating frame. Like, it's all inside this x prime, z prime plane, and we can define kinetic potential energy that way. So anyway, I'm excited. We have our first project. Again, the goal is you'll work on one of these repositories. So go to the list of join a group, go to the list of repositories, and then you can grab the code and start working from there. As I'm working on this, so if I wanted to take this and say like, okay, this is, let's call it my downloads, and project 01.jl. So I'm just putting it into my downloads folder. And one way to use how do we want to do this? We could try this. So I'll go to my downloads and look at the latest project 1, see if I can add it right in here. Oh, nope. Upload a file. There we go. And then I would say like, so this is kind of a small change, but let's whenever you're uploading things, like create a new branch and then try to merge that branch. It gives other people a chance to take a look at what you're doing, and even if everybody just says like, okay, great, you're proposing those changes rather than like directly pushing those changes in. So try to create new branch. You could call it patch 1, adding a Lagrange for simple pendulum. You can add any kind of, all this is just helping people understand like what you did. It's really important to document like what you're doing and how you did it. So using the Copilot Julia assistant, I gave it the Lagrange equations and kinetic and potential energy equations. Then I used symbolics to get the partial derivatives. So I'll propose these changes. And now anyone else who's going to work on this project 1-1, let's create this pull request. Now you can see that there's a new conversation because I'm like adding this Lagrange for the simple pendulum. You can add comments here of like at Cooper RC. Why are you using a simple pendulum when this one is rotating? And now I'm just talking to myself, but and we can see in here what's changed. So right now in the file, there's been changes to that project 1 file. You might end up with issues of like 2 people trying to change the same lines, and that's okay. You can merge things, and we can figure that out as it goes. The nice thing here is that whenever you use like GitHub this way, it's keeping track. Like right now, there's a conversation around what I did. There is a record of what files I changed and how many lines of code I added. So it's a whole bunch of like nice stuff to know. When we come back to the code, we can see there's 1 pull request from Cooper RC. You can merge it. You could say no, we don't want that. However we want to do it. Pretty cool. And this is our first project, so there will be some hiccups and stuff. There is a deadline, so let's come back here, make this a little bigger. I said March, first week of March, get this done. That doesn't mean that there's no late penalties for this being late, and you should be working like in these repositories anyway. So someone from the group should add a submission that is a link to the repository, so we can see who's working on it and how you're all contributing and what discussions are happening. So use the GitHub as a chance to like talk about like how you want to do things, what you want to do, and all of that. And we'll keep working on it together. You're not alone. This is not like go figure it out yourself. This is meant to be something where we're all working on this together, including me, where I can help on all 16 of these different projects and groups. Sound good? And with that, we'll wrap up for a short video today, and then I'll make another video where I'll show kind of the vibe coding session results with the pendulum, which is kind of cool. Let's do like a quick preview because I think it's kind of fun. The thing that I liked about it, it's got to rerun everything. So it'll just take a second. We can see the status running. But I'll walk you through, in the next video, I'll walk you through how I did this, and then I'll post all the code for this so you also have like a demonstration. The thing that I really liked was at the end, I told the AI like, hey, I want to see everything, the position, I want to see the velocity, and I want to see an animation of the thing moving, and I want them all in sync. Back again. Let's give that a second to run and take a look at. Oh, I have it running in two places. That's silly. And so another thing about Git and GitHub is that you can get really deep into the weeds of like version tracking and all of this. I think the easiest way to get started is just by saying like upload files this way. If you want to, so you can like you can download the notebook. So you would like click on this, run it in Pluto, and then come back and say upload file. And then you just upload whatever changes you made. You can like grab this and sync it to your desktop, and then keep the changes all kind of running that way. But you end up coming back and forth to this github.com page for your project version anyway. So it's 6 of one and half dozen of the other. And sometimes it gets more confusing when you're doing things through the command line and stuff. But if you want to use like VS Code or anything like that, it's totally fine. There's more than one way to work on it. All right, let's see. Did it work? So here's like the solution. And the weird thing was I didn't even give it an initial value. It just made this up. So if I want to change it, I could. But this was what I thought was the really cool thing. I asked for these 3 plots, and then it just made this pendulum motion kind of swinging back and forth over this time period. And I can see these changes happening in real time. And if I were to change this to pi over 2, I think pi works. Doesn't work? Let's say like 3. There we go. Yeah, that's what I was looking for. Where it's like really swinging around. Big swing down, big swing up. But anyway, kind of fun. So I'll walk through some of this, and also it'll be be good to kind of go through these derivations that we're working on here. Cool. All right. Then